friends, welcome to our podcast channel, The Storytellers. Stories about astronomy, the sky, the cosmos, motivation, music, history, and many things more.
Hello everyone. Today we are going to talk about the different types of reflecting telescopes. First we must know why we are calling them reflecting telescopes. In our daily-to-daily life, every one of us have often used mirrors to get ourselves ready for different occasions. But how do we do that? Basically, we get ourselves in front of the mirror and somehow we see a replica of ourselves in the mirror. And seeing that, we do the rest. The same thing happens in case of telescopes. We put the stars in front of some mirror and they also create their replicas using the mirror, and we observe that replica through the telescope. We know that the mirrors have only one side while the other side is coated by some material. Hence, when light falls on the mirror cannot allow the light to go to the other side because of the coating, and hence it sends the light back to the medium from where it came. This phenomena is called the reflection of light. Hence, the telescopes that are made by the mirrors are called the reflecting telescope. There are mainly 4 different types of reflecting telescope, such as Herschel's telescope, Newtonian telescope, Gregorian telescope, and Cassegrain telescope. Today we will discuss only 2 of them, the Newtonian and the Cassegrain telescope. In late 1668, Isaac Newton built his first reflecting telescope, which is known as the Newtonian telescope. It was the first usable reflector. In this telescope, a primary mirror M1 is placed at one end of a tube of large diameter, and the other end of the tube to focus towards distant objects to watch. The mirror M1 is a parabolic concave mirror of large focal length and big aperture. The parallel rays coming from a distant object AB are incident on the mirror M1. A plane mirror M2 is placed at an angle of 45 degrees to the axis of the mirror M1. And following the position of M2, we have placed an adjacent tube which consists of an eyepiece E along with a convex lens of small focal length and small aperture. The converging rays reflected by M1 are reflected again by M2, and a small real image A'(B') is formed between M2 and the eyepiece E. This image A'(B') acts as an object for eyepiece E. A magnified virtual image A'(B') of A'(B') is formed at the infinity. Finally, we can observe that virtual image through the eyepiece. Later, in the year of 1672, Lord and Cassegrain had published the design of the Cassegrain telescope. In this telescope, a large parabolic mirror O with a hole in its center is placed at one end of the tube. The parallel rays coming from a distant object are incident on the mirror O. Another small convex hyperbolic mirror M is placed in front of the mirror O. After reflection from the mirror O, the rays are incident on the convex mirror M. In absence of convex mirror M, the reflected rays from the mirror O would meet at its principal focus F0. Hence, in presence of convex mirror M, the rays coming from the mirrors O are reflected again, and a real and inverted image is formed at the point F. A convex lens E that acts as an eyepiece is placed at the back of the mirror O. The inverted image can be seen through the eyepiece. Here I have mentioned that both the telescopes needs a parabolic mirror. Let me explain why. We have seen that both the telescope needs mirrors with large aperture. But when a beam of parallel rays is incident on a concave mirror of large aperture, not all rays meet after reflection at a single point. Rather, they met at various points of the principal axis between f to f1. So the image becomes indistinct. This defect of image is called spherical aberration. But if we use a parabolic mirror, the reflected rays met it at its focus after reflection from the mirror. Hence, we can get an image free from spherical aberration. In spite of all this thing, the telescope has a small disadvantage. If the eye of the observer is positioned near the edge of the field of view, then stars look like comets. This type of defect is called coma. The formula of magnification of these telescopes is as follows. M equal to F naught divided by Fe. Here M stands for magnification. M naught stands for the focal length of the parabolic mirror and Fe stands for the focal length of the eyepiece. Again we know the relation F naught equals to R naught divided by 2, where R naught stands for the radius of the curvature of the parabolic mirror. Hence we get M equal to R naught divided by 2 into Fe. Hence if we want to magnify the image, either we have to decrease the focal length of the eyepiece or we have to increase the radius of curvature of the parabolic mirror. As of 2013, the largest reflecting telescope in world is the Gran Telescopio Canarias in La Palma, Spain, with a mirror diameter of 34.2 feet or 10.4 meters. Another stunning example of a reflecting telescope is the Hubble Space Telescope with a mirror diameter of 2.4 meters. So here we end our story of the reflecting telescopes. Thank you.